Hi, everybody. Today we're going to do a quick introduction to sets. So you might be asking yourself, what is a set? A set is simply a collection of objects. Those objects can be anything you want them to be, like numbers, users in an app, or items in a database. For notation, we usually name sets using capital letters. Then we list the elements of the set inside curly brackets. For example, we might have the set of seasons. S is equal to winter, spring, summer, and fall. Objects belonging to a set are called elements. We use the symbol epsilon to show when an object is an element of a set. Then an epsilon with a line through it shows the object is not an element of the set. As an example, 3 is an element of the set 1, 2, 3, while 4 is not an element of that same set 1, 2, 3. Let's decide if the object is an element of the given set. We start with 8 being an element of 2, 4, 6, ... The ... says we're continuing the same pattern. Our pattern is we're either adding to or just looking at evens. But in either case, the next number in the set would be an 8, so we say that yes, 8 is an element of the set. Next, we're trying to decide if 1 is an element of the set 1, 2, 3, 4, 5, which it clearly is. We can see 1 is the first element shown in the set. The next one looks very similar, but instead of having 1 as an element, we have the set 1. The set 1 is not an element of the set 1, 2, 3, 4, 5. We always want to check our notation. Since we don't have the set 1 inside of our bigger set 1, 2, 3, 4, 5, we say this is not an element. When looking at sets, what matters isn't what the objects are, it's that we're grouping them together as a single collection. As long as you can clearly say whether something belongs in the group or not, you can make a set out of it. This means sets need to be well-defined. Well-defined means that you can determine elements that belong to a set. For example, A equals the set of days in a week, or R is the set of all rivers in Florida. You don't have to be able to name the elements of the set, meaning you don't have to be able to name all the rivers in Florida. But the set needs to be described in a way that someone could do research to decide what elements were in the set. Not well-defined means the set is not described clearly enough to understand what elements make up the set. For example, if B is the set of beautiful cars made by BMW, or E is the set of fun math classes, we would say these sets are not well-defined. Beautiful and fun mean different things to different people, so we couldn't research what elements belong to the set and which ones do not. We have 3 different ways we can express a set. We have roster or listing method, word description, or set builder notation. Roster notation lists the elements in a set, which is why it's sometimes called listing notation. That looks like A equals the set 1, 2, 3, 4, 5, 6, 7, 8, 9. Or B equals the set January, June, July. In many real applications, we don't actually need to look at every element in a set. What we need is a clear rule for who belongs and who doesn't belong. For example, instead of listing every user in a system, we might want to describe a group of users who are over 18, or the set of files created today. In both cases, the sets could be huge and constantly changing, but the rule that defines it stays simple. To make things easier, we could write the set as a word description. A word description is a written explanation of the elements in a set, like A is the set of ages of employees, or C is the set of new clients. Our last notation is set builder notation. It gives us instructions on how to construct the set. We can have M as the set of all X, where X is the set of employees born in March. Or C is equal to the set 2X plus 1, where X is a natural number. Note, we read the vertical line as such that it separates the element X from the condition needed to satisfy the set's construction. Let's try writing the set A equals the set of 5x plus 4, where x is a natural number less than 4 in roster notation. Natural numbers less than 4 consist of the numbers 1, 2, and 3. Then, if I multiply 5 times 1 plus 4, I get 9. 5 times 2 plus 4 gives me 14. And 5 times 3 plus 4 gives me 19. This says my set A can be written as 9, 14, and 19. One last note to finish up our video. For sets, order doesn't matter and repetition doesn't count. That means if I write the set A as 1, 2, 3, or A equals 3, 1, 2, it's exactly the same as A being 1, 1, 1, 1, 1, 1, 2, 2, 2, 3, 3, 3, 3. The order and the repetition make no difference in the elements in the set.